That is from me. So now I would like to pass to our first, coach, Dr. Zati. Okay. So let me quit here. All right. So Dr. Zati, over to you. Can you share the screen?
Hello, good afternoon. Can you hear me?
Yes, I can hear
All
you.
right. All right. Let me
Yeah.
share
Can
my
you share the
screen.
screen?
Okay, coming up.
Okay then. Please go ahead.
Okay, thank you very much for the kind introduction, Prof. Siti. Hello, everybody. I am Dr. Zati Hakim Azizul Hassan. I teach at Department of Artificial Intelligence, Faculty of Computer Science and Information Technology, and that's my email. I'm coaching, mentoring, I think, two teams so far. Since Prof. Siti says you're able to connect, so feel free to contact me if you need help regarding um, drone AI integration. Okay, so without further ado, let me start my presentation today. Okay. Thunderstorm here at UM. This is some rough outline of my presentation today. I'll start with some motivation about drone and AI, and then I'll try to give you guys some projects example for this riot ideation. What my students have done in the past or currently doing. And then I hope that through explaining those projects, you get to see the components or the developmental blocks, what it takes to enable AI on drones. Okay. And my focus today, because I come from AI and my specialization is AI robotics, I usually combine robotics and AI together, and the sensor that I use the most, that I find um, most rewarding when you want to make quick, smart decision of the external environment through the eye of a robot or a drone, for me is vision. Very much less into other sensors for now, but I'm sure our engineering counterpart, Dr. Sofian, the speaker after this, can probably help out with that. So my focus today is mostly on vision, AI modeling, on drone. And I'd like to take, at this beginning, Prof. Siti mentioned this design thinking processes, the 6 steps. So I try to blend the processes inside my talk as well. So motivation, I think if you did some background check on drones are flexible, portable. It's actually very convenient to use and mainly used for data collection. Okay, so drones, data collection. That's like, I think, even in Malaysia, in the industry, drone, because of its aerial capacity, is able to move swiftly. It can reach to places that very hard for us to reach. Data collection is usually the main key function of drones. Uh, with AI and machine learning, for example, that data collection, the data that collected by the drone, you can further process it for intelligent decision making. So, for example, if you go into agriculture, which is one of our theme in this competition, probably can try to detect fungal diseases in plants, tomato leaves disease, for example. Or if you want to go into water conservation, I heard Islango is coming in. So water conservation and maybe prediction of the quality of the water. I'll give one example later. Okay. So I'll start with my first case study number one. So Prof. Siti mentioned earlier about empathizing. You need to start with something that you crucially believe. This is not too good yet for the competition level. This is what I extracted from my students' work, and I tried to update it a bit for today's presentation. Basically, you have to start with an idea. You have to empathize with the current environment. So let's say your goal is to work with conserving Lake, for example, and you saw there's a lot of trash, and you think, hey, why not I use a drone to maybe monitor, surveillance, the quality of cleanliness, water cleanliness at the lake. This is actually SDG 6 on water and sanitation. So let's say your problem statement or what you empathize about is to detect and classify floating plastic bottles, cups, bags, and water bodies. Okay, and then for the technical part in AI, this requires some reading, but YOLO V5, I think engineering student also use this. So YOLO V5 will probably be the right AI modeling that you wanted to use. And the entire overarching project is about enabling AI on drone monitoring system for water conservation. So you have to empathize, you have to um, get onto the field, do some field work, do a lot of research, and find this particular specific problem. So you might start with, oh, I want to take care of Lake. How can I support that idea? It's very broad. And then you have to go to the field, you have to, find the specific problem. So for this case study one, let's say the specific problem you want is detecting, classifying, or maybe counting. You want to send a report, the terrible floating garbage this week at Lake, or you want to say, oh, quite clean. That's good. Okay, so let's say this is the overall idea. You wanted to send a drone, and then the drone will do data collection using camera. Let's say this is what you want. You want to be able to identify foams or plastic bottles floating. Okay, so roughly the goal. So you need to start defining specifically what you want to, how you want to um, plan that blueprint Prosity mentioned. Okay, before you go to the prototyping, you need to plan really, really carefully, break down very carefully what you would require. Okay, and so for example, you wanted to make sure that you get a video stream from the drone because data collection, right? And then, yes, the idea is I want to identify. So colored bounding boxes should appear, okay, in my system. And then maybe I wanted to label trash or not trash, trash, or you want to say the type of the trash, plastic, foam, etc. Okay, and then number 4 here, display classification accuracy. So what is the model's confidence level? 75% sure it's a trash, or just 25% sure it's a trash. It's 25% and maybe you don't consider it as a trash. Okay? And maybe you want to use this to count. So for example, like on the left picture here, you can count 1, 2, 3 identified foam. Okay? Then you also need to carefully consider the data processing. So just like was the system overall, how you want the drone to behave, okay, and then or how you want your system, your output to showcase, okay, the elements in the element like if you're working on a website, what will the user see? What kind of output you wanted to deliver, and then this would be like the back end stuff. You need to understand if you are using YOLO V5, for example, it requires at least 600 images for the data set to be okay. Or maybe you want to also define, I think I'm good with 70% accuracy. Okay, so this requires a lot of research. Industry people might be interested in this part. They might want to know how big is your data set, how long did you train it, what's your model accuracy. Okay, so drone industry people, especially people from Meranti works with drone, they would know. Some drone comes with good resolution. Okay, you can even have drones that have 4K resolution, but in real-time modeling, you have to have that trade-off between the quality of the images versus the latency. So the higher the quality, and you want it to go through a long pipeline of processing, you will hurt your latency. You will get a very low latency. It will be a lot delay. So the drone has moved, but in the viewing of the drone on your laptop, it's still on the previous view. Okay, so latency versus quality trade-off is something that I think industry people would love to ask. You pick your brain on it. And then you have to decide earlier on. Okay, so a lot of research is required for you to come up with this. But if you have these things in your definition, it will really help you with your blueprint, with your prototype. Okay, so I talk a lot about dataset development. So when you work with drone as a data collection tool, and I said that if you're using vision, you need to grow your data set because AI model will need to feed on the quality of your data set. Okay, so just now I mentioned 600 images minimum. There's a lot of ways for you to get images. You can fly the drone and get your own images. Okay, or you can also, to help train the model, you can also go online because there's a lot of images available. Say, for example, from Google Images, you can download this. So these like some of the script you can write to find food waste on river, plastic on river, paper waste, etc. Okay, so once you found this data set, you need to save them onto your machine. Okay, so here I have 3 folders: metal waste on river, paper waste on river, plastic on river. And each of these category needs 600, if possible. If possible. If you can't, then okay, we'll see. You need to train a model and see whether you get that 70% accuracy or not. Okay. And then this is example of your data set. So as I mentioned, you're using that script and then download happens and then you get it into their folder. So in one of the folders, this is metal. This is like different images. Okay. But there's something else you need to do. So as I mentioned, you need about 600. So let's say you only get 200 images or maybe 100 images. There's a trick that you can do that we use in you can rotate the images. Okay. So for example, glass 11 here, I have a glass underscore 11 underscore 1 underscore 2 underscore 3 underscore 4. These are the same image, but I've rotated 4 times. So I generate more image. Okay, and this is very important for the model because the model needs to, you never know when a bottle will be upside down or you know, will be vertical or will be horizontal, upside down. So you never know what the drone will capture in the testing. Okay, so it's very important for you to have augmentation so that your model covers every angle of the object that's trying to detect. Very simple example, let's say I wanted to develop recognition, people recognition. I want to develop, let's say your iPhone has to detect your face in order to let you in. If you remember, if some of you using iPhone, you ask you to get 7 seconds of video input. So left, right, up, down, smiling, not smiling. So variation, same person, same face, but that variation will help the model recognize better. Same goes to this data set augmentation. Okay, so anything that you do that requires image processing, this is a very critical part. Okay, and then of course there's the model training. Hang on, my phone is, somebody is trying to let me. Okay, sorry about that. So then you will have to do that AI model training. So I hope those of you interested with this kind of work probably have some FSKTM students in it. But I do know a lot of engineering students have done AI modeling as well. So let's say, for example, in this case study one, wanted to use YOLO V5. There's a lot of script. There's a lot of ready model available on GitHub. You can download, or you can head onto like this very famous website, towardsdatascience.com. It will show you step by step how to train a custom object detection model. Okay, so there's a lot of places for you to do that. This is not the hard part. Okay, because you're not here to create a new model. You're here to just apply those models. But the more important part is your data set development. Okay, and then you have to also figure out your pipeline. How are you going to put all these things together? Drone, I think the one that we are going to use for this competition will not be industry grade. The one that I'm using, I think is slightly better than the one this competition is using. Even that, I can't do the AI on the drone. I have to transfer. Okay, so here you can see this is my drone transmitting live stream feed. Okay, you have to know some data protocol, right? And then you need to send it over to your maybe for layman's term, a laptop or a server or a cloud, where you have the libraries to receive the images, receive the video, and then do your AI stuff. Okay. This is the model training. So the classification happens in the model establishment. This is, see, data set, the live images, classify here. Okay, and there's something else that you needed to do. I probably, despite not the interest of this competition, maybe I think as long as you can show the output, not necessarily you have a web page output. Okay, so this is for Flask web deployments for web development. Probably you don't need this. This arrow can go straight to the report, okay, to the output. So for this case study 1, this is actually the result that we obtained. Okay, trash and 92% confident. Then the bottom one, 27% confident. So here you can make a decision. I just put it here just to show you the confidence level. And eventually we will not take the leaves as a trash because it's just 27% confidence. Just letting you know how the model training works and how you need to add another layer where you finally decide at what confidence level you want to allow the output. Okay, so let me continue further. Case study number 2. Let's say you're happy with this, but hey, I wanted to add more insights. Okay, just identifying trash might not be interesting to my stakeholder. Okay, maybe I want to add more information, more insights. And what better way than to identifying whether that trash is recyclable or not? Okay, because that means differently to the industry or to the agency that takes care of water body, for example. Trash can be, leaves can be trash as well, organic trash. But what about recyclable trash? How do we dispose them properly? Okay, so it might be an interest to fly a drone on the river, oceans. Okay, ocean is too far. We have rivers here, lakes, rivers. Then to tell the authority, hey, there's a lot of recyclable trash this river. You need to do a special collection, or this one has too many organic stuff. Okay, so there's a different. You might need different agency to come and dispose the trash properly. Okay, so more info, more insight. So let's say you want to extend this further, you can with AI, right? So I don't want to repeat the technical pipeline of case study 1 because it's exactly the same, pretty much the same. It's just an extension that we want to not just stop at trash. We also want to see whether the trash is recyclable or not. So every step of the method should be similar, except probably in the training model, where you specify trash, not trash. You also need to add classes like recyclables and not recyclables. Of course, the data set also will have some differences. So over here, maybe you annotated the data set as metal, paper, and plastic. Now you need another layer. If it's metal, or if it's paper, or if it's plastic, it's also recyclable. Okay, if it's organic leaves, it's not recyclable. You probably need to have that kind of layering. Yeah, so adding more classes. And then this is like what eventually what you want to get. At the end, it identifies or detect the trash, and then it says, okay, here plastic bottles is recyclable. And then that does not look like something that is recyclable. It looks like a stone, something else. Okay, so this can be more insightful to the industry or stakeholder, depending on what you empathize at. Okay. So let me go to case study number 3. Let me look at the time. Okay, good. Case study number 3. Let's say there's a different case study that you want to look at. You went to the lake one day and then you saw, hey, why is the lake so greenish? It smells. What's happening there? Okay, so you probably is facing algae bloom pollution. Okay? And if you go to the river, it looks so like theta red color. And then smells also, or maybe it doesn't smell. You start to like do some research. What's wrong with our river? Why it does not look nice as a Japanese river? Okay, and you probably realize that that's a sedimentation pollution. Okay, so probably it's nice to have a drone flying around and detecting this. Algae bloom is very dangerous. I'm working closely. Oh, sorry. I'm working very closely with the Water Warrior That's why probably a lot of my use cases are water related because I'm helping the water community with because they have a lot of chore. Okay? Collecting trash at identifying trash is one of their pain points. Um, when the algae is going to bloom, is at their pain point as well. There's a lot of parties in UM very interested with our lake water quality, so I'm supporting them. So the drone part of my work is usually on surveillance monitoring, and this is part of it. And we try to venture into river as well because river sedimentation issue. You see in urban areas, urban lakes, urban rivers, this is terrible sedimentation and algae bloom. Okay, so it might appeal to Meranti, might appeal to Ais Selangor, might appeal to stakeholders, might appeal to the scope of this competition for you guys to look into these problems. Okay? How you going to define which area you want to empathize is up to you. Okay. Again, this is for context. This is what algae pollution can look like. This is terrible. This is very bad. It's so greenish. Actually, green is still not bad. When it turns blue, it's even worse. Okay, but I think blue algae is usually ocean. Not really. I haven't seen it happen at UM Lake. Like the needs special contaminants to turn it to blue. Okay, blue algae. Green is usually what's happening at our UM Lake, and it really smells. I also have a water drone where I let the robot run on the surface of the lake. When the season when algae is bad, I take out my robot. It's like uh, muddy with algae. It's terrible to clean. Okay, it's terrible to clean, and if it comes to my skin, sometimes it irritates. So imagine the life under the water there, how they are trying to survive under this extreme condition. So it's a very interesting problems that a lot of communities in UM are interested at. A lot of researchers, water researchers, even someone from chemistry, very interested with what's happening at the lake. And monitoring the water quality is something that a lot of stakeholders in this country very interested at. Okay? This is sediment. I think you guys would probably be familiar with this. You look at your longkang-longkang, yeah, your parit-parit, then you see so they tarik color. And then this is like the picture below here. This is Klang River, also very famous for sediment pollution. Urban rivers, urban lakes. They're highly susceptible, very sensitive to this case. Okay? And it's, I think, quite a interesting use case also for a lot of parties outside who want to look at this. So let's say technically the goal is you wanted to do algae bloom classification or sedimentation classification. So you have to start building the definition. I don't think for the sake of this competition, let's say you're going for this type of problem, I don't think you have the capacity to build both. Okay, this is like two students of mine doing this work. I'm just combining, summarizing their work for this talk today. So you have to be you can think broad in the beginning, but you have to specify. So choose one, then let's say that's what you want, then let's go back to our definition. What would the system needs to do? Okay, so how high do you want to fly the drone above the water? Okay, you have to define all this. What is the resolution? If the model says I want 1024 times 768, but the latency then kicks in, it'll be too delay. So you have to have that balance. I have to probably reduce the resolution a bit smaller. That's why the accuracy okay, 65%, not 85%. Okay, so these are the things that judges, technical judges especially, would love to pick your brains at. Okay, process water body image captured during the daytime. Of course, this is very important unless you have night vision camera. Most of the project that you will do for this competition probably during the daytime. Maybe interesting to highlight that. Maybe not so important to highlight that, but I'm just letting you know. And then reflection is a bad thing for data processing. Sorry, for image processing. When you have reflection, parts of the images just turn white. Okay, so that's why how high do you want to fly the drone is very important. Okay, so if you want, you have to consider this as well. Okay, model requirement, you have to also think about the accuracy, and then latency. What is the delay that you would feel comfortable with? Maybe 3-second delay is fine before the result is out, or maybe 5-second delay is fine. This probably have to be justified in front of the judges. Okay? Because who would want a drone that do the collection, but the decision making comes like so late, like 1 hour after? And then that's not appealing. You would want a drone to fly, and then on your laptop you get to see, okay, this is what the result is coming. Okay. Okay, so let's talk a little bit about the development pipeline. Sorry for the typo. Similarly, image acquisition, data collection, 200 algae bloom images to be acquired. So this is just because of the limitation of my student. But for, again, as I said, depends on the model that you're using, YOLO V5, YOLO V3, or any other types, CNN, RNN, any other types of AI modeling. So it depends on that. Plus, there's not probably, let's say you have 200 algae bloom, probably that's sufficient. Okay, how more green do you want the algae to be? So it depends on your specific use case. Some might need more than 600, some might need less. Okay, and then this is image preprocessing. There's a lot of things you need to do. Okay, model establishment. This is very similar to the first case study, second case study. Image data collection, image preprocessing, model establishment. And of course, you can skip number 4, I think, for this competition. I don't think web development, web app front end is required, but maybe you have capacity to do that, even better. But if you are considering that, then you might look into Bootstrap, HTML, CSS, JS Notes, Flask. Okay, and most important is number 6, the result. Okay, so you can skip 4 and 5, I think. But 1, 2, and 3, I think is compulsory for your prototyping. There's like no excuse. 1, 2, 3, 1, 2, and 3 is blueprint, prototype. 4 and 5 is probably bonus. Okay, and 6 is very important. Okay. Data set development. Okay, so this is just for context. You can Google search the data set. You can fly out a drone. You can even use your mobile phone, go to the lake and take photos. But it's best to have a very good detection, a very good accuracy. For drone, it'd be best if you fly up the drone at that height that you specify and use the data set from that drone to train your model. That, to me, in my experience, is the best result so far, compared to developing or training the model using Google Images or phone images. Okay, so if you fly up the drone at that particular height, let's say 5 meters up, 3 meters up, okay, and you consistently collecting data at that height and train those things, and then when you want to do the testing, you fly the drone at the same height as well, and you should see a relatively better result compared to if you train it using whatever image you find on the internet. Okay, again, it's a result. So this is algae bloom pollution, confidence score 99.98%. So my student, I think one of my students did a lot of the model training. He tried all kinds of models, but he got 1 year plus to do this. So this competition is 2-3 months, okay, very, very short. So, but yeah, This is the output. Either you go for algae bloom or you go for sediment. Probably the most challenging one of the most challenging that I've tried is trying to classify paddy growth. there's a Malacca, I can't remember the farmer name, but there's this one farmer, paddy grower in Malacca, was asking for paddy growth classification system. The reason is he said that he has, I think, how many acres of land for paddy growing, and he would divide the whole land into sections. Okay, and when after harvesting and when it comes to seedling, he can't. He's a small farmer. Okay, he's not a big company. Most of the seedling is done by him and some of his workers. They don't have big machines, you know. So he says that it took him a while to finish one section. So let's say he has 10 sections, 10, 15 sections. Okay, it take him about 2-3 weeks even, or maybe a month to finish the seedling. Okay, and at the end, when it comes time for harvesting, the challenge is he will call his harvester. They will have machines, and even when he said, because he would say that, oh, I planted the seeds back in June. Okay, roughly this is a good time for harvesting. The person who harvests usually just harvests everything at the same time. So there are some sectors that are still immature for harvesting. So he needed a system to show paddy growth classification. Okay, then for today, harvester, please only take out sector 1, 3, and 5. They are matured. Okay, and other sectors tomorrow or next week. Okay, so that was the challenge. So we having the experience of all these case studies, so we were quite confident. We started to visit the farm and then take data sets. Okay? Happily taking lots of data sets. We went day 18, day 22, we went day 30, day 40, went to day 50, 55, day 65, 90, day 100. Okay? Getting data sets collection, happily getting. And then we would go through this pipeline, 1, 2, 3, okay, and number 6. And when we reaches the end, and because you see, when we were taking the data, you look at the size of the space you have in between each paddy seedling. Okay, and then when it grows, it got so close, the space is overlapping. So here you can identify 1, 2, 3, 4. Okay, here the machine's starting to have a lot of issue. Okay, so we didn't realize this. We did not realize this from the start. So the lesson learned was, are you able to distinguish paddy plant object from the background easily? If it looks like this, yes. If it looks like this, no. Okay. And these are so at 30 days, this is what we trained the model for, but the result is like this. So when we have a lot of space in between, some sectors has a lot more spacing, then our classification model works quite well. But when it's so bushy, it starts to overlap a lot, then it starts to get a bit difficult. The accuracy goes down. At 50 days, okay, and at 70 days, see, human eyes also very hard to see which one. Okay, and then 90 days. So what I learned, this is at harvesting. Okay, what I learned is, when it comes to agriculture, it's really not straightforward. Really not straightforward. So if you are really into agriculture, I recommend you to try. But you have to be mindful of what the output would be like. So if you go with like tree leaves classifications, sickness classification, I think it's fine because you probably can zoom in on the leaf a little bit. Okay, but canopy type classification like this, like Prof. mentioned, palm oil, the canopy, you have to consider the overallness of the, you can't consider the palm oil tree one by one. You need to take an overall assessment of that canopy line. Okay? So here, if I were to if I started with a previous season of, the overlapping bits, I'm probably able to train my model better. But because we were going or excitedly going, day 18, let's go. Then day 30, drive to Malacca, take photo. Day 50, go again. Then we fall short in terms of the developing a quality data set for the training. Okay, so I think that's all from me. I go back to my first slide just to recap. On the design thinking processes. So I hope I was able to introduce you some ideas for this competition. What it takes if you want to enable AI on drones, and the experiences that I shared today is mostly on vision. Okay, and I tried to show you which is the empathizing part, the definition part, ideation, and then what does it mean by prototyping, testing, implementation. Thank you. Maybe we have time for questions, Prof. Siti?
Yes, Dr. Zati, yeah, there are some questions. Please raise your questions and Dr. Zati will try to answer. Okay, go ahead.
Hi, Ahmad Abdallah. You have a question for me?
Yes, Doctor. Good afternoon, all, and Dr. Zati. Thank you
Yes.
for the nice presentation. So I'm Ahmed from FSK team, and I have two questions for you about the YOLO model.
Okay.
All right. So the first question is is YOLO V5, is it resource intensive? I mean, can I run it on Raspberry Pi 4?
I think it's fine because on Raspberry Pi, I don't think you can train much. So the pipeline that I showed today is mostly you training it offline. Okay, so you train the model elsewhere, use your Jupyter notebook, use your Google Colab, you build your data set, and then you train it elsewhere as a different pipeline. Okay, so let me go back to this one. Okay, so here you build your data set, and then you do your model training separately.
Yeah, of course.
Okay, yeah, and what's best for now, I think, because I know that the type of drone that we're going to work with will not be industry grade, so it's quite impossible for us to bring this model on board. Okay, so what you're saying is try to do it on Raspberry Pi, isn't it? So my suggestion would be to transmit this data over somewhere to your client, to your server. So it can be your, so send it somewhere. So you need to learn some protocol, send it, just that data from the drone, okay? And then you do this model establishment, this will be on your laptop. Okay, so yeah, and then you generate that output. But the trick is to have that drone still flying and your laptop showing these bounding boxes appearing.
Yes. But actually, Doctor, we have kind of a solution for this one. But basically, our plan is to, of course, to train the model outside the Raspberry Pi in a stronger server. But we just want to run the model just to identify the images in the drone.
Sure. You can download just the inferencing model.
Yeah, that one.
But if you want to put it on Raspberry Pi, good luck. Which Raspberry Pi do you have? You have Raspberry Pi 4?
Yeah, Raspberry Pi 4B, 4GB RAM.
Okay, then you have the latest one. It has quite a lot of capacity. Maybe you can try. Make sure the model size is less than 200 meg.
Sure.
200 MB. Yeah, you need it to be compact. But the nice thing, if you're able to do that, the nice thing would be, because if you have a smaller inferencing model, then it means the model accuracy might be smaller. Okay, it might be smaller. Let's say compared to RNN, those big ones. So you may be able to increase you may be able to reduce latency. So it means you don't have, if you put it on your Raspberry Pi and then image comes in, you do your detection, inferencing, and then you get your result. So it will be very fast.
Yes.
But whether the accuracy is good. So you need to appeal, let's say you're going with this flow, you need to appeal to you need to showcase the strength of you are giving a solution that is real time. There's no latency, pretty much. The trade-off is probably a little bit less accuracy, but hey, I'm giving you a solution where I'm able to reduce latency, because latency is not a good thing. Okay?
That's not a good thing. All right, thank you. And my second question is kind of a follow-up. Is like when labeling your data set. So if you are taking 600 images, that means you have to label each image manually. You have to draw a box around it.
Yeah, pretty much, yes.
Oh,
if you download, even if you're downloading, you still, because only you know the terms, the labels you want to use for your classification. Yeah. So exactly. At the end of the day, you have to label each one manually. RoboFlow is there to help you. Right. What are you using for data annotation?
We haven't yet decided.
Okay, so there's tools for that. So just so you know.
All right.
Okay.
Okay. Thank you, doctor. That's all for my question.
Thank you.
Okay. Any other questions?
Don't be shy, please. Anyone thinking about agriculture? Or maybe if you want to have a separate discussion, you can contact me. My email address is zati@um.edu.my. Okay.
Okay, thank you very much, Dr. Zati. Thank you for that, overall, process flow for this for your project, which essentially captures what the participant would have to do or may need to do. Okay, so that slide actually is very helpful, and it shows that if the team are able to demonstrate that sort of process step by step, break down the big problem into small problems, solve it one at a time, and you add up, and that will convince the judge to to see that the process is taking place. Okay. All right. Thank you very much, Dr. Zati.
Thank you. Thank you very much for the opportunity. Good luck, everybody.
Okay. Thank you.